right medication can save a life, but a medication that works well for other people might not work well for you. Hi everyone, my name is Rashad Hamsi. I'm a pharmacist and currently I'm doing a master's degree in bioinformatics. Today, I'm going to give you a short talk about the term pharmacogenomics. And I'm going to use PowerPoint slides in order to increase understanding and focus. We will start by this first slide. Here you can see the term pharmacogenomics, and this term has two parts, pharmaco and genomics. Pharmaco stands to pharmacology, is the branch of science that deals with study of drugs. And genomics stands to the branch of science that deals with study of genes. And wherever you see this term, you will see this slogan with it, the right drug to the right person at the right time. And actually it's a kind of abbreviation of the definition of pharmacogenomics. Talking about the definition of pharmacogenomics, and you have to know that pharmacogenomics, sometimes called pharmacogenetics, and they both used interchangeably. If you want to know details about this, pharmacogenomics refers to analyzing a person's entire genome, whereas pharmacogenetics refers to analyzing a single gene or a set of genes. So please don't get confused, Anyway, so pharmacogenetics or pharmacogenomics is the study of how our genes affect the way our bodies respond to medications because of our genetic makeup. This picture shows different kind of people have different types of metabolism. So some people, are slow metabolizers. Their bodies break down certain medications too slowly. The medication builds up in the body, causing severe side effect. So they need half a normal dose to show effectiveness. While other people are rapid metabolizers. So their bodies break down the same medication too quickly, eliminating it before it has a chance to work at effective levels. So, in order to know what kind of person you are, pharmacogenomics testing can identify variation in specific genes related to metabolizing or cleaning certain medication from the body. And the main goal of pharmacogenomics is to avoid harmful and unwanted side effects of a drug before, treatment with it. We can see here, its long-term goal is to help doctors select the drug and doses best suited for each person. It's part of the field of precision medicine, sometimes called personalized medicine. You have to know something very important. The target here is patient. Finding a healing treatment for this patient, not finding a treatment for this disease. Here, everyone is unique. Here, one size doesn't fit all. So, precision medicine aims to treat each patient individually. In this slide, we have a very important question. What role do genes play in how medicines work? Most genes contain the information needed to make functional molecules called proteins. But those genes are not similar to each other, We have different versions of the same gene. Each version has a slightly different order of nucleotides in DNA. So some of these variants are common and some are rare, and we have to know those genes variants that link to certain diseases such as cardiovascular, cancer, and diabetes. So scientists here know that certain proteins affect how drugs work. Pharmacogenomics here looks at variation in genes for these proteins. Such proteins include liver enzymes called the family of cytochrome P. They chemically change drugs, and those chemical changes can make the drug more or less active in the body. Even small differences in the gene of these liver enzymes can have a big impact on a drug's safety or effectiveness. You have to know that pharmacogenomics wouldn't be able to study genes without using the databases that bioinformatics provides. So, pharmacogenetics and bioinformatics both meet in drug designing process. Bioinformatics provide a wide range of drug-related databases and softwares. Likewise, pharmacogenetics provides the genome-level information about the variable drug response. And I want to take the chance here and tell you about a very important site called PhamGKB. That stands to Pharmacogenomics Knowledge Bases. This is, the display of this site. PhamGKB is a comprehensive resource that provides knowledge about the impact of genetic variation on drug response. Actually, it's an interactive tool for researchers investigating how genetic variation affect drug response. I will leave you the link of the site in the description below. If you have time, go and check it. It's very important. So here we have to know what was the past of pharmacogenomics, what is the present of pharmacogenomics, and what will future hold. The first person spoke about pharmacogenetics was Hippocrates. He said, "It's more important to know what sort of person has a disease than to know what sort of disease a person has." This is the first idea of precision medicine. After his words, the idea developed a lot. Today, pharmacogenomics testing is available, which can help predict how an individual may process and metabolize hundreds of different medications, including those used to treat cancer. And I have to mention something very important here, that we have many applications of pharmacogenomics in oncology, and there's a very famous example that has already practiced in many countries with a drug called azathioprine. Azathioprine used in the treatment of a patient with ALL, acute lymphatic leukemia. So here we study the TBMT gene, and the TBMT gene provides instructions for making an enzyme called thiopurine S-methyltransferase. So those drugs that include 6-thioguanine or 6-mercaptoprine or azathioprine inhibit the body's immune system. So the TBMT enzyme turns off thiopurine drug by metabolizing them to inactive, non-toxic compounds. So it's very important to study the gene of it in order to know if this drug will be active or harmful for the patient, And actually last week I attended a lecture in the University of Cambridge. It was an online lecture about precision medicine. They talked about the future of precision medicine in the treatment of chronic disease such as COPD, asthma, and diabetes. So if you are interested in this, I will actually leave the link of this lecture in the description. You can have it whenever you want. So this is the end of this short talk about pharmacogenetics. I hope that I have conveyed the information well to you, and I hope that this lecture has provided you with the desired benefit. Thank you all for listening, and thanks a lot for watching.